Motor stator. Three-phase powering, three-phase powering, three-phase powering. In this situation, I have two three-phase motors facing each other such that their rotation is opposite of each other and coupled at the output shaft. In my experimentation with three-phase motors, I find it beneficial that the motors only have one electrical connection between them. In this case, I will choose phase 1 to be my connection between the motors. Normally, when connecting motors that are spinning in opposite directions, you would have to change two of the connections for opposite rotation in this manner. But since we are not connecting these motors in a conventional manner, we are going to use phase number 2 of each motor to connect to phases of 220 volts. This will be the supply power that causes the motors to rotate. For the system I am building, these two motors coupled together will be the rotary phase converter for the system, as well as supplying additional supplementary rotational power. In this next diagram, I will show the way that I intend to apply power to these motors for the most beneficial efficiency and operating temperature. As you can see, I will connect phase 1 of both motors together, then I will apply power of two separate phases to the same phase number of each motor independently. At this point, I will connect capacitors from phase 2 to phase 1 and from phase 3 to phase 1 of each motor independently. These capacitors will be of the same ratings on both motors, provided both motors are identical. Because the power being applied to the number 2 phase of both motors is to separate phases, and of itself the motors will spin opposite of each other. Here I will diagram the capacitors that I spoke of earlier and how they were affixed to each motor independently. The two hash marks that look like a sideways pause button represent the capacitor in the diagram. The motors will run in this configuration of a standard 220 single-phase electrical supply, but they must be rotary started with a drill or some other form of rotation. I am using two marathon motors in the system I'm building. They generally operate at a range of 100 to 120 F. The two that I am using in this configuration currently operate at around 92 F. This constitutes a rotary phase converter per each motor individually, meaning another three-phase motor can be hooked directly to the three phases of each one of these motors. Independently, they must not be connected together unless